Hello, my name's Alec. I am the technical manager at Quelfire, and this is another episode of Burning Questions. In this episode, we're going to be looking at fire testing once again. So I'm joined with our R&D head, Darryl Wells. Thank you for joining, Darryl.
Right, yeah, I'm Darryl, a development director here at Quelfire. So I work with the team to create solutions, so research and development. So in particular, fire testing, which is what we're discussing. But I do also deal with our supply chain and work on a few other long-term development projects to create, again, solutions for the future.
I suppose I know we've done a couple of episodes of Burning Questions already about fire testing, but I think there is still quite a lot of confusion out there, especially with some of the customers I deal with on a day-to-day. So I think if we start at the beginning and then we'll look at what Quelfire have done specifically. So can you sort of explain, hopefully in sort of layman terms, what is fire testing as such for fire resistance perspective?
Yeah, sure. So I guess fire testing is really trying to put your products or system through a test, which is to simulate what would happen in the event of a real fire in a building. So test standards are developed, and I suppose there's really two key conditions in the fire test standard that we test most of our products to. That being 1360 EN 1366 Part 3 and EN 1366 Part 4 for linear joints. So typically there's the time temperature curve, is what we call it. So I've actually got a bit of a example here of the time temperature graph. So this is where you can see here there's the temperature versus the time, and you can see that it goes up to 600 degrees within the first few minutes of testing. And this is simulating a flashover fire, which I'm sure we've explained on other videos and other episodes as to that process. In my opinion, it's probably a more onerous than what would happen in real life. But that's great as a standard. It's putting your products and systems through a test standard, which is more onerous than what would happen typically in real life conditions in a building. Should a fire break out in a building. So yeah, that's typically the test standard. There's also a pressure that's applied in the furnace as well, which is one of the other critical conditions, which is typically around 20 pascals within the top of the furnace. So yeah, there's a couple of conditions there: heat and pressure, and that's what we put our products and systems through to prove that they will work in the event of a fire in a building.
Yeah, no, that's great. So I mean, obviously you've mentioned what standard we do. So are all the test standards the same, or are they different? How does that work?
Yeah, they would vary depending on what you're testing. For service penetrations, we obviously got a specific standard, and the standards try and cover as many eventualities and different services. So there's guidance on cable sets and pipes, etc. But I would say that standards don't always cover the reality of what comes up on projects. So there is always challenges for us trying to create solutions when the test standard doesn't give the exact guidance that we perhaps would like to be definite about how we do things. But yeah, that's just a constant challenge because the construction moves on, and so does the test standards have to follow, and there's always a bit of a lag. So
yeah, definitely a lag. Obviously, for a lot of people, don't probably realise it's holding still to Europe. It can take some time. I mean, for example, BSEN 1366 Part 3 was the old version was 2009, and it was updated at the end of 2021. That was quite a long case, and even to be well, we both agree that even the most latest up-to-date version is still missing out quite sizable chunks of service penetration applications that are quite common probably on most sites nowadays. So it is definitely a challenge. So with that in mind though, I suppose, and this is again what we're getting, a lot of people seem to think fire testing is probably a bit easy, is you just sort of delved on it a little bit. What are the challenges of trying to test? Is it just simple, we can just build something and chuck it on a furnace? Does it work like that?
No, because there's a lot of variables that you have to consider. So there's supporting construction, there's again there's development of services over time and different piping systems, different types of insulation. etc. And so it's a constant moving program, as it were, because you're responding to what is happening in the marketplace and trying to create solutions that prevent the spread of fire in these buildings. So, yeah, a classic example, I suppose, is plastic coated copper pipes has come up, and we've done some development testing on that. So, you know, traditionally it's just copper pipes and maybe insulated, but you know, the development of I think it's PE coating on copper pipes. Now that's to do with the interaction of phenolic insulations, for example, and how that can affect the pipe work. So this has come in as a challenge, and we've responded by doing some fire testing.
Interesting with that test, by having something as simple as a PE coated copper pipe vastly changes the fire resistance that we've actually achieved on the application with something. I think it's only 3 mil thickness. It's tiny change, but it's had actually quite impactful fire ratings for what we've had previously in this side of things. So it was good that we've tested it, because it's not as simple of surely it wouldn't cause any difference. It did cause a difference, so we've got that evidence to back that up. So yeah, no, it's good to see that. I suppose also as well is one of the things, going back to challenges, is, you know, the equipment that we actually have to use for fire testing. There's quite a lot of limitations with that side of things, from boundaries on the wall furnace to, well, floors, for example, load bearing aspects on that. The people don't probably realize there's quite a challenge with the equipment that we have to use as well. Limiting factors, I suppose, is the best word for it.
Yeah, there can be, yeah. So interaction of different products that are tested to different standards, whether that be structural standards interacting with a wall, for example.
Yeah.
We've had challenges to try and create some kind of solutions there, but
yeah, no, it's quite interesting. I obviously get a lot of requesting from the technical team about certain factors, and they don't realize that we are beholden to some things. A lot of people would like us to test first server supports at further distance, but there's 2 factors there. One, there's only so much room in a fire test furnace, depth, but also the test standard is actually quite specific. There's certain service types can't go past a certain distance anyway. So cable trays, metal pipework shouldn't go past 500 mil. So despite the fact that you may want it 700, 800 mil, it's just not feasible, or within the test standard as well.
I guess that's another thing. You're limited to, you know, the furnaces that are available. You can't actually penetrate a meter into most furnaces anyway.
No.
Just because the way that these furnaces are built, etc. So there has to be some limitations. Yeah.
So obviously we're in the middle of well, not middle, but we're start of 2026. Was 2025 another good year for Quelfire with testing?
Yeah, absolutely. There's a few developments going on, particularly around different wall types, wall constructions, and floors for that matter. So yeah, different sandwich panel types.
Yeah, we did the power up side of things as well.
Yeah, and shaft wall.
That was a big one.
Single side install. But then we've got things like profile decks with larger apertures that we went through a testing regime there, and with steel lined apertures. So different supporting constructions is a huge thing, because our products perform in their own right, but it's the interaction with other, you know, whether they're sat within a floor or sat within an opening in a wall. It's testing the interaction.
Yeah, and again, like going back to what I said earlier, is you have to test them all, because they are different results. So shaft wall, for a lot of people may have thought, why, surely we could just use our standard wall data, but there are differences from the way they're installed, how the walls behave, especially as they're typically asymmetrical walls, not symmetrical. So
yeah, and shaft wall in particular, the deflection is substantially different to a standard flexible wall typically, because the steel stud on the shaft side is exposed, and therefore the heat from the furnace when tested from that direction.
So obviously, just in case, when you mean deflection with this, what do you mean?
Not deflection of the head of the wall. That's a good point you raise. It's the deflection of the wall from a movement point of view. So, you know, either deflecting into the furnace or away from the furnace, and things different things can affect that deflection. And like I say, with the studs, steel studs in a shaft wall, that can have an effect on how they perform.
So when we've done the testing, for example, the shaft wall, you've had to test it from both directions purely because of that factor as well.
Yeah, from that factor, but also from the most recent testing we've done an installation from a single side, which again is asymmetrical. So it's ensuring that, you know, the side you can access and butter up the bat and make everything neat. You can test it from the other way where you haven't been able to do that and still perform. So there's proof in testing from both directions. Basically.
Yeah, no, I already know they've been highly sought after. So it was a good end of 2025, and that's why we got those details out quite quickly for our customers, etc. So, and I know the Paroc systems, which we've done ASTF, ASTL, and ASTF Plus. Remember off the top of my head, there's so many different sandwich panels that's gone down quite well, and they're quite big for data centers and stuff like that.
Just on that, you've mentioned a couple of different types. Typically, the difference is around the density of the rock fiber and the steel panel and the width of those type of walls. So they do have there is a variation between them.
Yeah, no, and that's where it's quite clear on our details with that side of thing, because we've also tested Euroclad side of things. So our sandwich panel makeup's proving quite large. But yeah, supporting construction of the profile deck, when you mentioned, I thought was really good. So that again was good feedback of, we had solutions where it was the QF2 directly to the concrete, with it being quite thin in places, thicker, but the aperture's quite small. So we had some feedback. So do you want to just talk about what we've tested?
Yeah, so that particular test was a larger opening. I can't remember the exact size, but
1600 by 1100.
1600 by 1100 with a steel lining, as they would generally do with that size aperture on site, and then proving the interaction of our QF2 compound within those sort of openings. So, but profile deck is you know, we see it on so many projects, and I suppose along with that, we've also done development last year with wall interaction up against the profile deck. So typically the wall manufacturers will recommend, well, flexible walls, a plasterboard wall, is there's a glass rock board on the head, and then the wall is fitted to that. And we've tested interaction with our Quelfire bat system within the profile infills above the glass rock board. We've also done some work with a three-sided opening, builder's work opening with our bat system interacting and the inch-foam product up against the glass rock board. So
yeah, we've actually done quite. Going back to the shaft, where we did header wall testing in that as well. So we've actually quite increased the header wall range that we've got for builder's work opening, which has proven very successful.
Yeah, and again, we've done other linear joints last year as well. Again, head of wall, not just profile deck, but other linear joints, and some fire ratings up to 240 minutes, which is great for some areas on projects where they have, you know, for example, basements. They've got substations, got blockwork walls, and they need a increased fire rating.
There was actually quite a few unique things I think we tested last year. So you mentioned obviously the PE-coated copper pipes, but is there anything else that springs to mind that was quite unique that we tested last year?
There was plastic cable trays. It seems to be becoming more of a popular requirement. They're actually typically yellow, bright yellow cable tray systems. So we've done some testing around that with successful results. But you want to explain the reasoning behind these plastic trays typically?
Yeah, I mean, obviously the main reason we approached is, especially for sort of Ministry of Defence projects and stuff like that, they don't like to have metal where they could actually be, you can tamper with them and put listening devices and stuff like that through metal. It's around a subject like Tempest and stuff like that. Going back to my old army days, but yeah, so they tend to use the plastic one, but there might also be reasonings why metal might not be suitable for certain areas from corrosion or atmosphere and stuff like that. So plastic can be quite utilized in certain places. So, but unfortunately, no one had a tested solution as I was aware of. So yeah, I mean, it's not, I know when this video is coming out, it's not readily available on our Quell Selector, but if people reach out to me, I can give you all the information with that, because we did the cable set on it, and it's got a quite reasonable fire rating on that one as well. But we didn't just stop at plastic cable trays. We looked at plastic trunking as well, which was quite new. Obviously, a lot of trunking is normally metal, but you do get the odd instance for that. So we've got some solutions on that. Probably going back to what we said earlier, is testing is one part of the puzzle. I don't think many of our customers realize what happens sort of between.
If you're talking about from a test, then you've got a classification which has, it's not a summary, it's a field of application
It's just
of
scope, the defined scope. And
could
stuff.
be, and in our case, lots of fire test reports creating a scope and then the scope of application. Then obviously there's the ongoing certification,
which can take some time, unfortunately. It's not easy. Obviously, we tend to get our fire test reports back quite quickly, but in some cases we don't. I know we can be waiting up to a year sometimes for a test report, and then you've got the added length of the classification. So we have made the conscious decision to release certain things, like the shaft wall stuff is released slightly earlier than what we would tend to do, but we are aware that certain projects need certain solutions right away, but we do have some caveats with that evidence. But yeah, that side of thing is going, but because there's other solutions like we've done now, large steel pipes, I think 600 mil.
And we've also done specifically some stainless steel, which is
250 wasn't it?
Yeah, which comes in a very thin wall. Again, that's something that we acknowledge. There's so many different factors, and one of them being pipe wall thickness.
Yes.
In our scope of application, and we've perhaps not always had those some of the wall thicknesses that are available on the market, like pipes,
smaller stuff.
So we've actually done something about that, and last year in particular we nutted out some of the gaps in those scope that we had. Example, 110 mil PVC pipe with 3.2 mil wall thickness. In our initial scope, we didn't have that coverage, and we acknowledge that, but we went out and specifically included tests with those wall thickness pipes to create those solutions.
They're proven very popular, and again, I suppose for people outside there, this is where, well, I find Quelfire quite unique, is we're listening to that feedback. We're not fully out there in the industry. We're a manufacturer of the products, but 3.2 mil UPVC is very common in the UK, but it isn't for the rest of Europe. So most manufacturers have tested pipe wall thickness ranges that covered Europe, and 3.2 mil tends to have been missed off for a lot of people, but we've gone back and got solutions through walls and floors covering that type of aspect. But again, going back to what I said earlier, some people might say, well, surely you've done 4.2, 3.2 can't be that much of a difference, but there can be a difference.
There can be,
yeah. And you've got to have that evidence to check things through. But yeah, going back to wall thicknesses and sort of feedback, was one of the big things we tested last year was copper pipes. Most manufacturers, again, we don't tend to do smaller than 42 mil because larger pipework covers smaller pipework, but it's that wall thickness. A 15 mil copper is 0.7 mil, whereas a 42 is 1.2, and we didn't have that range, so we've gone back, done specific testing on the smaller copper pipes. We've also gone back and done testing on smaller thicknesses of certain laggings that the M&E reached out to us and said, look, for phenolic, we can go down as low as 15 mil, not 25.
And I guess on those, it's not that it was successful, the fact that we tested smaller pipes with a thinner wall thickness, and it's not that. It was more a case of ensuring that our scope actually had that black and white answer of between this and this.
It just saves that ambiguity of it should be okay. Now we know it is okay. I like that. I think last year we did a lot of unique stuff, the wall constructions, but we're also looking at those small little gaps because of the feedback of going, okay, how do we get the most out of our scope of application, which has been good. So I suppose, if we did so much in 2025, does that mean we're not doing anything in 2026?
Yeah, we're just having a bit of a break. No, so yeah, we've got plenty, and again, there's more interactions of different floor types. Again, we don't like to, shout about things that we haven't got yet, but there's things in the pipeline that are happening for increased wall constructions, floor constructions.
A lot of the stuff this year is obviously a few unique things, like you said, supporting constructions, a few different service types that we might not have ever tested before. But I suppose it's also just filling up any voids. But one of the things I think been quite unique with the planet that we've done for this year is there are common scenarios that have never been thought about or tested by anyone from what I can see. And we've got plans to get that sort of those overlooked aspects covered this year, haven't we? So
Yeah, and I guess there's you know, small, very small things that may have been overlooked, I suppose. But it's creating solutions and doing what we can to ensure that everyone can achieve compliance on site through knowing that what they have installed is correct and is having that black and white evidence and paper trail.
yeah, no, it's definitely going well. It's actually just whilst we've been talking, I've just remembered a big one that we did last year that we didn't talk about was the timber stud stuff,
Yeah.
which I thought was actually quite game changing as well. So for those out there that might not realise that most manufacturers test on metal stud walls, and that evidence can be used on timber stud walls, but there is a caveat, and that caveat is that any penetration must be 100 mil from the timber stud, and in between the stud and the penetration must be non-combustible A1, A2 rated insulation. So that can cause quite a lot of problems on sites because you can have things like socket boxes, conduits, partial penetrations, much closer to that. So we've gone and done some specific testing on that last year, didn't we?
Yeah, we did. Yeah, specific interaction with timber studs from a letterbox or a builder's work opening aperture with our coil stop bat system, but also, like you say, sockets with our putty pads. So partial penetration is something that penetrates, say, one side of typically a wall, but doesn't penetrate right the way through. So yeah, your conduits down to your socket boxes, etc. And there isn't a standard for that is a formal published standard anyway, but there is one in the making and has been for a few years now. But we haven't just waited. Let's wait till the partial penetration standard. We've gone out and done things to the principles of, because these are common scenarios on site. Again, it's creating documentation, black and white evidence that our customers can rely on.
Yeah, no, it's been quite good. I know, in fact, going back to that sort of standard things, it was good that you highlighted that because yeah, the standard is in draft form for partial penetration. It's not coming out yet, and someone actually commented on one of our videos. But we're aware of the draft and we know what sort of is in there. I think it's a bit lacking in places personally, but with our test evidence, what's sort of fundamental is because it's part of the BSEN 1366 range, like part 3 for full, part 4 for linear gaps. It's why we've gone for that route. I know other people sometimes used the wall test standard, that side of things, but the way we've done it and worked with our accreditation body is, again, probably going back to what you said at the start, probably over the top, more onerous than what it would be in real life. But we'd rather prove something works in the worst case scenario. Obviously, this might have been quite short and sweet, and I appreciate your time because I know you've been quite busy at Warrington Fire with the other members of the R&D team getting ready for the big tests and that. So that's it from us. Thank you very much. Take care.